Generic routing encapsulation. Now, GRE is a tunneling protocol which was developed by Cisco, which allows you to have virtually a point-to-point connection between two different sites over any transit network. Now, the transit can be an internet or it can be any other service provider network. Now, if you're using internet as a transit network, just ensure that you are using the public IP on both the sides and you have reachability between the source and the destinations. Now, it is used to send your packets from one network to another network over internet or insecure network. And the good thing about this GRE is it's going to support some multiple protocols, like it's not only supports your normal IP traffic, like the transit can be an IPv4. We can send IPv4 traffic to IPv4, and probably the service port is running IPv4 or internet, whatever it is. If it is internet, you need to have a public IP on both the sides. Or it can also be used, let's take an example, you have IPv6 traffic and probably the customer on both the sides using IPv6 and your transit is running IP version 4. So what we can do is we can allow you to have an IPv6 network to be sent over an IPv4 network by using GRE tunnels. Now, GRE is going to encapsulate the packet, like your traffic will be, normally the traffic when it comes here, it will be an IPv6. But once it reaches the router, as we have a tunnel here, it's going to add some outer extra overhead packet, which is going to add some source and destination IP addresses. And the sources and destination addresses will be based on IP version 4. Now, your packet will be routed from here to here based on the outer header, which is built after the GRE configuration, and it will be removed on the other end. And once it's removed, and it's going to send as a normal IPv6 packet. Now, the same thing happens in case of internet also. Let's take an example. I'm using my private IP addresses where I'm using 192.168.1.1 network, and this 192.168.1.1 network want to communicate with 192.168.2.1 network over internet. Now, once it reaches the router, as we have a tunnel, it's going to add some outer overhead where the source address will be 15.0.0.1 and the destination address will be 25.0.0.2, the public IP addresses, so 15.0.0.1 and 25.0.0.2, and your packet will be routed over the internet based on the outer header, and it reaches the other end. And once it reaches the destination of the tunnel, probably it will remove this outer header and it will send as a normal IP packet. Now, that's how GRE is going to work in general. Now, not only that, it will also allow you to run some routing protocols, like we can have a tunnel established between router 1 and router 2, and we can have an OSPF or EHRP neighborship established between them. It allows you to run a multicast traffic. It allows you a multicast packets, that routing protocol traffic, as well as you can also have some IPv6 traffic allowed on it. Like we can have an IPv6 customer on both the sides, and we can allow you to have an IPv6 to IPv6 communication over IPv4 network by building some GRE tunnels. Now, one of the things you need to keep in mind, the GRE information is not encrypted, so which means the information goes in a clear text. That's something not much secure. Now, GRE is one of the easiest implementations, easiest configurations to implement if you want to have normal tunnels. But one of the major drawbacks with the GRE is they do support only point-to-point. That's one of the things. And also, it is not going to provide any encryption. So there's no encryption methods, or it doesn't encrypt your information when it sends over the other network. Now, configuration wise, it's really a simple and very straightforward configuration. If you want to build a logical point-to-point tunnel, like in this scenario, I have a network 192.168.1.1 network, which is my private network here, and I want to ensure that this 192.168.1.1 network should communicate with 192.168.2.1 network on a remote branch office, that is a private network, and I'm not using a dedicated lease line or any other WAN connections. I want to have virtually a point-to-point connection built between these 2 points, that is from router 1 to router 2. Now, I'm connecting both the sites via internet, and I have some registered public IP addresses on both the sides. Now, the public IP on the router 1, which is my source, is 15.0.0.1, just assume that, and the public IP address on the router 2 is 25.0.0.2. That's the public IP address what I'm using for tunnel source and tunnel destinations. Now, first step, we need to create a tunnel. And to create a tunnel, we just need to go to the interface and we can use any number, tunnel 1, 2. So I'm building the tunnel from 1 to 2, so I'm using 1, 2. And then we can define tunnel source and tunnel destination options. Now tunnel source, it can be an IP address, or we can also define the interface name. Like in my scenario, either I can write an S1 by 0, or we can write a 15.001, the source IP address, and then we have to write the tunnel destination. Now, one thing you need to keep in mind, you must have a reachability between these two tunnel source and destinations. If there is no reachability between the source and the destinations, the tunnel will not come up. So that's a mandatory thing you need to keep in mind. So just ensure that you have reachability between the source and destination before you go with the tunnel configurations. Now after that, once we configure this tunnel source and destinations, it's going to build a logically a point-to-point configuration between the router 1 and router 2, and then we can assign our own IP addresses. Now our own IP address, we can simply go with 10.0.12.1. that is something what I'm using here. We can assign an IP address and then 10.0.12.2 on the other side. Now it looks just like as if we have a point-to-point connection between the router 1 and router 2 via tunnel 1, 2. So that's the interface which is connecting between these two. Now they both look as if they are directly connected with each other once you finish up with the configuration. And if you try to ping from 10.0.12.1, it's going to ping to 10.0.12.2, just like a normal point-to-point interfaces. And we can also run some EHRP or OSPF protocols, because GRE supports any of the routing protocols we can implement, allows you to send the multicast traffic over the tunnels, and we can establish the EHRP or OSPF neighborship over the tunnel interfaces. So it's really very simple and very straightforward configurations when it comes to GRE configuration. So probably we'll get into some practical verification of the GRE in our next videos.